Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Evaluating Algebraic Expressions. So let's quickly review. To evaluate an algebraic expression, that means we're going to find the final answer or value of that expression. That's what it means to evaluate an algebraic expression. So the word algebraic means it's going to have at least one variable. And when you're given expressions that have variables, you're going to do two basic things. You're first going to substitute the variables with the numbers that they are equal to. And what they're equal to, that will be given to you in the directions. Secondly, you will evaluate the expression using the order of operations, which you recall what that is. That would be PEMDAS, or as some people call, please excuse my dear Aunt Sally. So let's take a look at problem number one. Now, problem number one, for those of you who have the guided notes printed out, is already 100% done for you. So you can just follow along here on the screen as I talk you through how this problem would work. Now, before we go any further, I should point out that the directions say to evaluate each expression, and they tell you that A is equal to 5, they tell you that B is equal to 12, and they tell you that C is equal to 4. We have to pay attention to these directions because the very first step that we're about to do on each of these problems is we're going to substitute the numbers in for each variable as it was given in the directions. So in problem number one, we have AC plus 2B. Now I need to point something out to you, something I talked about in an earlier lesson. When you have a variable next to another variable, or when you have a number next to a variable, that is going to mean multiplication. So AC, A is 5, C is 4. That's not going to be 54. It means 5 times 4. The same thing with 2B. Since B is 12 and there's a 2 on the left of that 2B, that doesn't mean 212. It means 2 times 12. So this is something you have to keep in mind throughout this entire packet of guided notes. You have to understand that when a variable is next to a variable, that means multiplication. Likewise, when there's a number next to a variable, that also means multiplication. And we're going to show multiplication with a raised dot. Now, from here, we have to follow order of operations. Are there any parentheses on problem number one? No. Are there any exponents from problem number one? No. Is there any multiplication or division? Well, yes, there is. Here we have multiplication, and here we have multiplication. And since there is addition in between, we can go ahead and do both multiplication sections at the same time. So 5 times 4 is 20. 2 times 12 is 24. And notice we saved the addition for last because order of operations tells you that you should do addition or subtraction last. 20 plus 24, that's going to give you 44, and that is the final answer. That is evaluating the expression, which means coming to a final answer for that expression. All right, what I want you to do right now is try number 2 and number 3 on your own. So hit pause on the video, do number 2 and number 3 on your own, and then hit play when you're ready to see how you did. All right, I hope you already did number 2 on your own. If not, please hit pause now. Let's go ahead and see how you did. First thing we do is we substitute. 3C is 3 times 4. AB is 5 times 12. According to the order of operations, you should do parentheses first, but there are no parentheses here on this problem. Then you would do exponents next. Well, there are no exponents on this problem. Then you would do multiplication or division next. We have multiplication here, and we have multiplication here. We can go ahead and do both of those multiplication sections at the same time because there is addition in between, which would be done last. So 3 times 4, that would give you 12. 5 times 12, that would give you 60. Now, if you want to do those two multiplication sections at separate points in your work, that would be okay. So you don't have to get the 12 and the 60 at the same time. If you don't want to, if you want to get the 60 a little bit later on, that would be totally fine. Now from here, we have addition and subtraction. Should we always add before we subtract? The answer is no. If you look back on your guided notes that I gave you in a lesson earlier than this one, you will see that with addition and subtraction, you are supposed to do them going left to right. And since the subtraction on this problem is further to the left than the addition, That is why we will do the subtraction before the addition. So 20 minus 12 is going to give you 8. And then you do 8 plus 60, which will give you 68. Problem number 3. If you have not done number 3 on your own, please hit pause on the video and do it on your own at this time. Otherwise, here we go. First step, we substitute the numbers in for the variables. Remember, 14a means 14 times the value of a. 6c means 6 times the value of c. Now, from here, this problem is different than the ones we've had so far. This problem has parentheses. And whenever you have parentheses, you are supposed to do what is inside of the parentheses first. And you don't just go left to right inside of the parentheses. You have to follow the order of operations even when you are doing the problem that is inside of parentheses. So what I mean by that is you need to do the multiplication before you do the addition. So 6 times 4, that would be 24. Now, why did I not do the 14 times 5 yet? It's because it's not in the parentheses. So you really shouldn't be doing stuff that is outside of parentheses when there is still more to do inside of the parentheses. Notice the parentheses are still being drawn here. Why? Because there's still more to do inside. As I had taught you in a previous lesson, the parentheses should not disappear until you have done everything inside of those parentheses. So we still have more to do. 12 plus 24. That is 36. And at this point, the parentheses can go ahead and disappear. Now that I have done everything inside of the parentheses, now I can start looking at the stuff that was not in parentheses, and that would be the 14 times 5, which would give you 70. Now, I'm not going to lie to you. If you got the 70 earlier than you technically should have, like if you made 14 times 5 become 70 right away, I'm not going to lie to you. It would not have messed up this problem. But you got to be careful. You have to understand what you are doing. You have to make sure that you realize that on some other problems, if you would multiply something that was outside of parentheses, it could potentially mess some things up. So this is why the steps I'm showing you here on my screen, I am making sure that I know what I'm doing. I'm making sure that I did everything in the parentheses first before I even bothered to look at anything that was outside of the parentheses. And I would advise for you to do the same. Finally, 70 minus 36, that is going to give you 34. Now, I want to point something out. If 70 minus 36 is not something that you can normally do well in your head, there is nothing wrong with going off to the side and doing 70 minus 36 and then doing the borrowing work that would need to be done to figure out that it's 34, where this becomes a 6 and the 0 here becomes a 10, and then you would subtract. 10 minus 6 is 4, 6 minus 3 is 3, and that's the side work. I like to call this side work, the work that I do off to the side before I can figure out that that answer would be 34. All right, moving on. Problem number 4 and problem number 5. They look almost identical, but if I could point out the obvious here, number 5 has parentheses, whereas number 4 does not. So let's go ahead and have you try number 4 and number 5 on your own. So hit pause in the video, do number 4 and number 5. When you are done, then hit play to see how you did. All right, I hope you've already done number 4 and number 5 on your own. If not, please hit pause now and do these problems on your own. So both of these problems are going to start out very similarly. You're going to substitute. The C is 4. We know this from the directions. So we substitute the 4 in for the C. On number 4, there are no parentheses. So the next thing you would do in order of operations is you would do the exponents. So on problem number 4, after you substitute, the very first thing you're going to do is 4 to the second power. And that would be 16, because 4 to the second power means not 4 times 2, it means 4 times 4. But number 5 is going to be very different. Number 5, as I've already pointed out, has parentheses. And whenever you have parentheses, you are supposed to do whatever is on the inside of those parentheses. And on this problem, the exponent is not on the inside. If it was on the inside, then you would be doing that first inside of the parentheses. But like I just said, it's not on the inside. On this problem, the only thing on the inside of the parentheses is the 5 times 4. And that is why 5 times 4 should be the very first thing that you do mathematically in this problem after you substituted the 4 in for the c. So notice how number 4 and number 5, as you can start to see now, are ending up to be very different kind of problems. Because on number 4, we already did the exponents. 4 to the second gave us 16 because there were no parentheses. Now we would do 5 times 16 and we would get 80. And like I was saying earlier on problem number 3, if you ever have to go off to the side and do a little side work multiplication, kind of like I did side work multiplication back on problem number 3, there is nothing wrong with doing that. I'm not saying everybody has to do side work. If you can do 5 times 16 in your head, that is great. But if you need to go off to the side, no big deal. Now, to finish off number 5, 20 to the second power. That means 20 times 20. Some of you could probably do that mentally in your head. Others of you might need to go off to the side and figure that out. But kind of like how 2 times 2 is 4, 20 times 20 is going to be 400. And so as you can see, number 4 and number 5. Number 4 did not have parentheses. Number 5 did have parentheses. They end up being very different kinds of answers. Moving on, number 6 and number 7. Number 6, for those of you who have your guided notes typed up, is already 100% done for you. So if you just want to quickly look at your screen, I will talk you through this problem. First part, we follow the directions. We substitute the numbers in for the C and in for the A. Now, on this problem, we have a complex looking fraction. And I've told you before that whenever you have a math problem inside of the numerator of a fraction and or a math problem inside of the denominator of a fraction, then there are technically parentheses around the numerator and parentheses around the denominator, even though you didn't see the parentheses on the original problem. It's like they are there even though you don't see them, almost like they're invisible parentheses. And so what I'm really trying to tell you then is whenever you have a math problem in a numerator of a fraction or a math problem in the denominator of the fraction, here we have it in both, you must do the numerator and the denominator's math problems first, just like they were in parentheses. Now, is the 11 times 5 in parentheses? No. But the 3 times 4 to the second is technically considered to be in parentheses, and the 17 minus 5 is technically considered to be in parentheses. Now, what do I do with 3 times 4 to the second? Well, you would do exponents first. This is not like problem number 5, where the exponent is on the outside of the parentheses. This one, the exponent is on the inside, where that 4 is located. So you would do 4 to the second first. Now, in the denominator, you're allowed to do this 17 minus 5 right away, just like you do 4 to the second right away, because there are 2 separate sets of parentheses. And that is why 4 to the second is going to give you 16. 17 minus 5 is going to give you 12. Now, there's still more to do in the numerator. We have 3 times 16. That would give you 48. Why did I not do 11 times 5 at the same time that I did 3 times 16? It's because 3 times 16 is considered to be in parentheses, as I was explaining earlier, whereas the 11 times 5 is not considered to be in parentheses because it was not in the numerator or denominator of a fraction. Now, from here, I have taken care of the parentheses part for the order of operations. There are no other exponents other than what I originally had in the numerator of the fraction. So the next part of order of operations is to do any multiplication or division that we might have in this problem. And we have both. The fraction bar means division. Obviously, the raised dot here means multiplication. Since there is addition in between, we can go ahead and do the division and the multiplication both at the same time. So 48 divided by 12, that would be 4. 11 times 5, that would be 55. And now we can finally add them together and get 59. All right, now that I've led you through number 6, why don't you go ahead and try number 7 on your own? So hit pause on the video, do number 7 on your own, then hit play when you're ready to see how you did. All right, I hope you've already done number 7 on your own. If not, please hit pause now and do it on your own. Otherwise, here we go. First step is to substitute. So C is 4, A is 5, B is 12. Now I apologize, this almost looks like that I'm writing 40.5. That's supposed to be a raised times dot. So I apologize if it looks a little bit unclear. Those are supposed to be multiplication symbols, not decimal points. There are parentheses on problem number 7, just like I was talking about on problem number 6. Whenever you have a math problem in a numerator, that is considered to be in parentheses. You don't necessarily have to draw them. I'm just drawing them here on your screen to make my point. Same thing with the denominator. We have a math problem in the denominator, so that is considered to be in parentheses. In the numerator, there's only one thing to do, and that's 40 times 5, so that's going to be 200. No big deal. But in the denominator, there's multiple things to do. What would I do first according to the order of operations? I would multiply the 5 times 12. So that would give me 60. Now notice, I am not touching the part of the math problem that is to the left of the fraction, the 2 times 4 to the second power. I am ignoring that because that was not in parentheses. You're supposed to do everything that's in parentheses first. And there's still more to do. We still have 60 minus 14 plus 4. As I mentioned earlier in this video, with addition and subtraction, you are supposed to go left to right. So since the 60 minus 14 is further to the left than the plus 4, then that's why you're going to do 60 minus 14 before you add by 4. 60 minus 14 is 46. Finally, 46 plus 4 is 50. Now I have done the entire math problem in the numerator, the entire math problem in the denominator, which means the parentheses part of this very long mathematical expression, the parentheses part has been done. So now, what do we look for? We look for exponents, and we do have some. 4 to the second power would be 4 times 4, which is 16. So next, we look for multiplication and we look for division. And very similar to problem number 6, here we have multiplication and we also have division and we have this addition symbol in between. So what that means is I can go ahead and do the multiplication and the division at the exact same time. So 2 times 16, that's going to be 32. 200 divided by 50 would give us 4. And if you thought it was going to give you 40, think about this. If I had 40 50s, that's going to be a lot more than just 200. Because 50 plus 50 is 100, plus another 50 is 150. It only takes 4 of those 50s to make 200. Finally, we add them together, and that's going to give us 36. And there you go. That is the last problem from the guided notes called Evaluating Algebraic Expressions. Thank you for watching. We'll see you next time.